So this next piece we're going to look at is some more solving polynomials, and this is going to be ones that are what we call quadratic in nature. So they're going to be kind of factored like we factored quadratics, but they're actually not quadratics because, as you can tell, this is an x to the fourth, not an x squared polynomial. So in order to be quadratic in nature, there's a couple of specific things it has to have as features. One, it's going to have three terms. So we have 1, 2, and 3 terms. Again, to solve it, we need it equal to 0, just like when we solved quadratics. The other piece with the 3 terms for it to be considered quadratic in nature is your last term is always going to be a constant, and then your middle polynomial degree will always be half of your leading coefficient or leading term's degree. So here we go from a fourth down to a second, and then it's gone, or the x isn't there anymore. So we could have like a 6, x to the 6th, and an x to the 3rd, and then a constant. We could have an x to the 8th, x to the 4th, and then a constant. So those are kind of the different ways to look at this. So since this is quadratic in nature, we're going to factor just like we solved quadratics, or factored quadratics. And so the idea was going to have 2 parentheses. The difference, though, is that each parenthesis is going to be x squared versus just an x, because x squared times x squared is our x to the 4th. Now the reason why these are the same as quadratics is I'm going to find what goes in the end of each parenthesis by finding 2 numbers that multiply to 2 and also add to 3, just like we did before, and that would be 2 and 1. So I'm going to get x squared plus 2 and x squared plus 1. Again, similar to what we did with quadratics, since there was no lead coefficient here on the x to the 4th, or it was 1, these are a little bit easier to factor and solve. We'll do one in a minute that doesn't have a lead coefficient of 1. Alright, so now I've got each of these parentheses, each of these factors are quadratics, and I could see if I could factor them further, and I'm missing that middle term, that x term, and so the only way this even works is it has to be a subtraction in here, which it's not for either of these cases. So I'm just going to set each parenthesis or each factor equal to 0, which again is what we do when we solve. So I've got x squared plus 2 equals 0 and x squared plus 1 equals 0. I'm going to solve for x. So again, it's just got a single unknown x in there, so I'm going to isolate it. So I'm going to subtract 2 from both sides, so I get x squared equals negative 2. And to get rid of the square, I need to square root. Again, as I move on, don't forget the plus or minus, very key. Every quadratic is going to have 2 answers. So I get x equals plus or minus the square root of 2. Since it's negative, I can't take the square root of a negative. It becomes an imaginary answer. So I'm going to pull out that I out of the square root. Remember, I is equal to the square root of negative 1. So really what I've done is rewritten negative 2 as negative 1 times 2 and split it into 2 square roots. And so I'm left with the I that I pull out and then the square root of 2. So there's 2 of my answers. Plus, or the positive I root 2 and the negative I root 2. I'm going to do the same thing up here with this quadratic. So I'm going to subtract 1. So I get x squared equals negative 1. Again, taking the square root, don't forget that plus or minus again. So x equals plus or minus the square root of negative 1. And the square root of negative 1 is I. So I get x equals plus or minus I. And so there are my 4 answers. Again, it's a 4th degree polynomial, so it should have 4 solutions. So I get x equals, I root 2, negative I root 2, I, and finally negative I. And so there are my 4 answers. All of these are imaginary. So what happened in later ideas when we graph this, what this means is this graph, x to the 4th plus 3x squared plus 2, if I made this equal to y, you would never actually see this guy cross the x-axis. This graph would open up and it would be above the x-axis because none of the solutions, none of the zeros or roots are real. They're all imaginary. So let's look at a second example of this. So I got 3x to the fourth minus 4x squared equals 4. Again, I've got three terms, but it's not equal to 0. So I've got to subtract that 4 over to the other side. So now I get 3x to the fourth minus 4x squared minus 4 equals 0. So again, one of the ideas from here is I can try to factor it like it's a quadratic in nature. It's got, again, three terms, constant as the last one. The middle power is half of the leading term's power or exponent, so that seems to work. But I've got this leading coefficient of 3, so this is going to be a little bit tougher. So I'm going to go back to the old methods that we did, which is product, sum, and numbers. Product comes from a times c, so 3 times negative 4 is negative 12. Sum is my b value, or negative 4. And so figuring out those two numbers, negative 6 and 2, pop up as solutions for me. Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Alright, so now I'm going to take this and put it in the box and use that box method to factor this. So first term, now again, be careful, it's 3x to the fourth. And then this two numbers that we found, negative 6 and 2, are not going to have x's on them, they're going to have x squareds. Because again, the negative 6x squared and the 2x squared have to add to negative 4x squared, which they do. And then the last term is negative 4. Alright, so now I'm going to look to factor out 3x to the fourth and negative 6x squared. I can pull out a 3 and an x squared. 3x squared times what is 3x to the fourth? That's x squared. 3x squared times what is negative 6x squared? That's negative 2. And then x squared times what is 2x squared? And that's 2. And again, just kind of check. Negative 2 times 2 is negative 4. So I've done a good job with this. Alright, so now I found my factors. Both are quadratic, so I get x squared minus 2 and 3x squared plus 2 equals 0. Alright, so from here I'm going to have to set each factor, each parenthesis equal to 0. So we're going to start with x squared minus 2 equals 0. Add 2. So I get x squared equals 2. Again, square root. And don't forget the plus or minus. So it's plus or minus the square root of 2. So there's two of my answers, positive and negative root 2. So now we're going to focus in on the second parenthesis, 3x squared plus 2 equals 0. Again, solve or isolate the x squared so I can solve for x. Minus 2. I get 3x squared equals negative 2. Divide by 3. I get x squared equals negative 2/3. Take the square root. X equals, I'm going to get that plus or minus, and since it's negative, I'm going to get that I out in front. So I'm going to get plus or minus I times the square root of positive 2/3. Okay. Now, in future, we can probably show you how to what's called rationalize this, but I think at this point in time, that's probably good enough for us to leave it like that. So I'm going to get my final four answers. Again, it was the fourth degree, so I get the positive square root of 2, the negative root 2, and then my I times the square root of 2/3, and finally my opposite of I, or negative I, times the square root of 2/3. Ran out of room a little bit there, but I think you get the idea. So 4 answers, 2 of them are real, the square root of 2, and the opposite of the square root of 2, and then 2 of them are imaginary. I times the square root of 2/3 and negative I times the square root of 2/3. And that's how you solve things that are quadratic in nature.